The unit of torque in the SI system of a unit is underscore A, kgm, B, kgcm, C, Nm, D, N/m2. When a shaft is subjected to a twisting moment, every cross-section of the shaft will be under A. Tensile stress, B. Compressive stress, C. Shear stress, D. All of these. The shear stress is minimum at A. Axis of the shaft, B. The outer surface of the shaft, C. Anywhere inside the shaft, D. None of these. The shear stress varies from center to the surface of the shaft with A. Uniform rate, B. Linearly varying rate, C. Remains constant, D. None of these. The shaft is made of underscore A. Mild steel, B. Alloy steel, C. Cooper alloys, D. Any of these. The shafts are designed on the basis of underscore A. Rigidity, B. Strength, C. Both of this, D. Either of these. The product of the tangential force acting on the shaft and radius of shaft known as A. Torsional rigidity, B. Flexural rigidity, C. Bending moment, D. Twisting moment. The polar moment of inertia of a solid circular shaft of diameter, D, is underscore A. Pi d3/16, B. Pi d3/32, C. Pi d4/32, D. Pi d4/64. The polar moment of inertia of the hollow shaft of the outer diameter, D, and the inner diameter, D, is given by underscore A. Pi d3-d3/16, B. Pi d4-d4/32, C. Pi d4-d4/64, D. Pi d4-d4/64D. The torque transmitted by a solid circular shaft is underscore A. By FSD3/4, B. By FSD3/16, C. By FSD3/32, D. By FSD3/64.